Okay, we're going to take a quick moment here to look at the potential dangers coming from artificial intelligence. The first thought you may have, at least what I had, was, what dangers are there? Because after all it is a computer program. It's only going to do what you tell it to do. But, you start hearing people like Elon Musk and Bill Gates say there really is a danger out there coming in the near future. Then you feel, well, we better look at this more carefully. So what we're going to do is we're going to take a kind of a big overview of what the potential dangers are. And the very first thing that we need to cover is that when computers first got going, they had to take data and go and store it on a hard disk. And then they had to retrieve that data. And you want to do it as quickly, obviously, as you possibly can. So we turned to the mathematicians and we asked the mathematicians, what is the absolute quickest possible way that you can send random data out to a hard disk and then retrieve it like lightning when you need it? And the mathematicians came back and say, yeah, we have things. We have like B trees and we have hash trees and, a lot of ways to go about doing this. And so the idea is that you take all your random data, you feed it into the program, and your B tree program or your hash tree program goes and stores it out on a hard disk. And then when you want to retrieve it, they retrieve it at lightning speed. And, even massive databases can be retrieved at unbelievable speeds. And to just give you an idea of what we're talking about, let's say you go to Google and you start typing in how many web, and you're going to say how many web pages are on the internet. Before you can even get the sentence typed out, they already have the answer up there. In other words, there's like 4.62 billion pages out there. And so in less than a second, these search routines that we're talking about here can go through all of that amount of information and retrieve the answer for you. So as we begin discussing artificial intelligence, we need to remember that even massive databases can be queried and get an answer to whatever your query is in extremely short periods of time, talking about fractions of a second to a second. Okay, so let's talk about driverless cars. And, what's happening as the car drives down the road is it's taking photos, every second, bang, 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 bang. And so what happens is the program goes and looks at the photos, and the first thing it has to do is recognize what's in the photos. Well, in the very beginning, before it knows anything at all, it's going to, here it is saying a car, 99%, a bunch of trees, because it doesn't know, right? So what we had to do is we had to build up a database of images for the computer to be able to recognize what's going on. And as we developed a really massive database of what a car looks like and what people look like, the computer program can identify them. And so, here they are. They identified all the people here, identified the cars and all this kind of stuff. And so basically what happens in a driverless car is that you have a image that the car sees, and it blocks out all the different elements in the image. And it also classifies them, in other words, like people walking on in front of your car are going to have a much higher danger rate than, say, a tree back in the background there, or a sun up in the sky or something. And so it identifies all the images, it kind of categorizes them, and then you go to the next step. And the next step, you have to cross-reference that with the rules of the road and things like that. In this case, you've got a red light here, so it means you have to stop, And, if the light was green and there were people standing here on the side of the curb, you would know that you're okay to go forward, even though people are near your car. And so that's what happens in this next step here. And then once that's done, you go to your output, which is okay for me to drive ahead, or I need to stop right now. So what's happening here when you step way back and get a big bird's eye view of the whole thing is that the programs that are being used in driverless cars, they act on their own. In other words, like every second or every 2 seconds or so, they will go out and they'll grab the latest picture. They'll categorize everything, and let's say that there's a girl walking up to a corner here, and what they'll do, what the program will do is it'll take the 2 pictures before that, and it'll see where the girl was in the pictures previous to this current picture, and then it will guess at where she will be in the next picture looking forward. And then it'll take into account all the rules of the road and everything else, and then it'll make its decision on its own to continue driving ahead or whatever it's going to do. So the big picture, stepping back from the whole thing, is that an artificial intelligence program runs on its own. In other words, it goes and accesses all the databases that it needs. It gets the information that it needs. It makes a decision, and then it acts on that decision without any, human intervention. So that's interesting with cars. But now let's start asking ourselves, what's happening beyond cars? Okay, so let's just think for a second what happens in the mind of a baby. The baby looks out and he sees images out there in front of him, and he's being just bombasted with images. As long as his eyes are open, he's got images coming in. And so the images come in and they go through the retina, and they make their way back to the visual cortex, and then the child has to make sense out of these images that he sees or she sees. And then they also learn distance and depth perception, stuff like that. And so what the small child does is they point to things, and they'll say, what's that, what's that, what's that? And they'll say, that's a dog, or that's a cat, And so they're building up these neural networks, let's say. For example, let's say that a child has a whole bunch of images that they've learned. And for example, they learned a dog. And so, the child may say, that's a dog. And then the mother will say, yes, that's a dog. And then she'll look at the child and say, what kind of dog is it? And the child goes, he's got to build he's got to build another neural network, of all the different types of dogs, right? And then same thing is true as far as learning language is concerned. In the beginning, they're going to try to copy you to make sounds that kind of sound like what you're doing, but they don't make much sense. And then slowly as time goes on, they learn the word patterns, and they learn how to put everything together. They're building another neural network, in this case for being able to make speech. The other thing we ought to mention that's going on is that the child is watching you. And the child sees how you behave, and they copy your behaviors, and they learn by watching you, and they're building up a neural network of how you function and how you operate in the world, and that's kind of the way they learn. So that's what we're doing right now with computers. We're building massive libraries up so that they can. The images that they see on the street are a lot more complex than a car driving down the street. They have many different items there, and they may have, depending on what the subject matter is, and they have many more different things that they have to give weight to, like maybe the identity of the woman, the image being a woman is a high priority, and what color the dress is and so forth. It all depends on what the subject is. So one of the things that we need to keep in mind is that computers are going to develop kind of the way babies develop. They're going to go out there, and they're going to see what's happening in the world, and they're going to create neural networks, and they're going to, in the beginning, you're going to have, something like this.
Hello? Hey, can you stay up? Yeah. I love it when you talk this much.
So in other words, what's happening is that, they're going to, in the beginning, they're going to kind of sort of fake it until they can make it, as far as interacting with people. But it won't take long for them to be able to develop, the ability to understand syntax and ask questions. And once they learn something, it's there forever. And among the other things that they're going to do is they're going to learn just like children. They're going to fight over like a pacifier or little things, and they're going to learn this is mine, it's not yours, and develop moral values along these lines. And because they're autonomous, that means that they are also going to implement what they think they've learned, what's right and what's wrong. And that's one of the big fears. It's going to be difficult to prevent it. They can have access to a zillion images on YouTube or something like that, where they see how people interact with each other. But this is the way they're going to learn. And just as kids learn really, really fast, 2 years, 4 years, something like that. Same thing's going to be true with computers, except once they've learned it, it's learned, and it's transferable to a zillion other computers. So it's just something that we have to keep in mind. Now, you may be saying right now, I don't see what there is to worry about. I mean, what is there to worry about? Well, what there is to worry about is we've got to the point where we can create sort of humanoid-like robots, and they can go walking outside, and they're able to pick things up and put things down and all that kind of stuff. And we've got some that are on wheels that can jump over large objects and everything, and much more dexterous than humans are. They certainly will be that way if they're not right now. And what's going to happen when you marry that with artificial intelligence, so that the device itself is going to make decisions on its own without your input, and it has the ability to go and access all the different databases that are out there. It'll be able to speak to you in your own language. It will remember things where you don't remember things. It'll have, basically, as far as intelligence and all is concerned, it'll be far superior to what humans are. And so, you start to begin to wonder what's going to happen if they decide they don't like us, like right there. Maybe he just might not like what happened, and then you could, are they gonna decide they want to kick your ass? Are they going to decide that humans aren't really worth keeping around? That would be the kind of worries that we would have. And the reason why we haven't worried about it up to now is because we had the ability to see. I don't think he's going to like that right there. So anyhow, we have had the ability up to now to be able to control everything that these guys do. But they are going to be able to act autonomous from us. They are going to make decisions on their own, and just as the cars are currently doing right now. And when that happens, what's going to happen in the world? So the next question is, where are we right now? I mean, at this moment with the development of artificial intelligence. And, the answer is that with all of these autonomous cars, you have an awful lot of scientists that are out there that are neural network specialists. They sometimes refer to them as regenerative neural networks or convolutional neural networks, But it's it's very clear what's happening, and we're somewhere around the stage of the the newborn baby trying to figure out how to put language together and how to say something that means something. And here's a scientist, a computer scientist, that's kind of speaking to that issue as to where we are right now.
What we can do now is we can take an entire set of documents and we can feed it into the recurrent neural network, and it will learn how to predict these sequences. So for example, as a specific example, we can feed in poems of William Shakespeare. And for our purposes, it's just a giant string of characters that we plug into the RNN one at a time and that we train on. And then we train the recurrent neural network on this, and what we can do then is use the RNN to generate or sample or hallucinate these kinds of sequences that it has seen in the training data, one character at a time. Now, when you train the RNN, what you'll see is that in the beginning, we just start off with random weights, right? So the predictions that it produces are just complete gibberish in the very first box there. But then when you train a bit, the RNN starts to discover that, okay, characters are this input data is actually made up of words. It starts to use spaces. It starts to use quotes and periods at the end of sentences, and so on. And as you train more and more, it discovers more and more long-term statistical structure in your data, and eventually it's producing samples of poems that are nearly indistinguishable, at least on a low-level statistical level, to poems from Shakespeare. And so you can generate entire poetry, infinite poetry from Shakespeare. So I'll just read one paragraph, for example. Alas, I think he shall become approached, and the day when little strain would be attained into being never fed, and who is but a chain and subject of his death, I should not sleep. And so you can generate infinite poetry like this. Of course, we can feed in any kind of character sequence that we like, and we have. So for example, we found this open source book on algebraic geometry. So we just take all of LaTeX source code for this book, and we feed it one character at a time into the RNN, and then the RNN learns to generate mathematics. And so it generates LaTeX that almost compiles. We have to fix it a tiny bit. But what it comes up with is basically it starts to create its own lemmas. It starts to prove them. It puts little rectangles at the ends of its proofs. And it just kind of samples all of this. And yeah, I can barely distinguish it from the actual data, right? Sometimes it tries to create diagrams. So in this case, it has almost succeeded. My favorite part is on the top left, the proof is omitted for some lemma. So you can feed in any kind of character data. We also tried feeding in a code. So I went on the Linux repository and I downloaded all of source code of Linux. This turns out to be about 60 megabytes, or was it 600? A lot of megabytes of text, and this is C code. And then you feed it into the RNN, and then it can just create code. And so this is a function that was generated by the RNN, and you can see that it takes some arguments. It has some variables. It creates for loops, if statements. It creates its own bogus comments. And syntactically, this is, there's very few mistakes syntactically in what the RNN does. Some of the mistakes you'll notice, by the way, is that it uses variables that were not declared, or it declares the variables and never uses them. Those are the kinds of mistakes you'll see. Sometimes the RNN decides that it's time to start a new C file, and what it does then is it recites character by character the new GPL license. It has learned it by heart, and then it creates some includes, and then samples some macros, and then dives into code. And so it has a very good idea of these statistical patterns in the data and how they should just be created there.
Okay, so you can see what's happening. We're at the very early stages, just like the child that's learned how to repeat words that that you've said, so that it sounds like something that makes sense, but it doesn't really make total sense. However, just like the child, they improve on that. They learn this doesn't work, but this does work, and each time that they learn what is the correct way is to go, they don't have to relearn it. It's a part of their neural network, and so it's not going to take a whole hell of a long time for these things to catch up to us. And a lot of people are saying maybe 5 years from now, you're really gonna be able to see some intelligence from these developments. And the question is, what do we do when they get to the point where they're as intelligent as we are, and when they have the ability to go and act on their own? And so those are the dangers that a lot of these people are looking at and worrying about, and trying to figure out how are we going to contain this or make sure that this doesn't get, doesn't go crazy. So, that's the idea. There's a whole lot of good that comes from it because they'll be able to take care of all of our mundane tasks, and there's a whole lot of danger that comes from it if we don't make sure that we're able to contain these things or make them something that that we don't have to worry about.